When an arc fault circuit interrupter or AFCI breaker trips, it indicates a potential problem within the electrical circuit it protects. Several factors can contribute to this, and a systematic approach is needed to identify the cause. Firstly, consider the possibility of a faulty appliance. The device plugged into the AFCI circuit might be drawing excessive current or causing a fault. Secondly, even if a plug tester indicates continuity, there could be internal damage to the type NM-14 cable insulation, resulting in an intermittent short circuit. Thirdly, poorly tightened or damaged connections at outlets or devices can overheat, causing the AFCI to trip. Fourthly, there may be other electrical problems in the circuit, such as loose neutrals or ground faults, that are triggering the AFCI. Here are some troubleshooting steps to take. 1. Inspect the appliances. Unplug all devices from the circuit and try resetting the AFCI breaker. If it stays on, the problem may lie with one of the appliances. Test each device individually on a different circuit to see if it trips the breaker there as well. 2. Check the NM-14 cable. Use an insulation tester, a megometer, to measure the resistance between the hot wire and the ground. A reading of less than 1 megohm may indicate insulation damage. 3. Inspect connections. Remove the outlets and switches on the circuit and check for loose or damaged wires. Ensure all connections are tightened securely. 4. Look for other electrical problems. Use a voltmeter to check for proper voltage and continuity throughout the circuit. Look for signs of overheating, such as discolored wires or burnt insulation. Now let's delve deeper into each of these potential causes and troubleshooting steps. Firstly, regarding faulty appliances, it's crucial to understand how an AFCI breaker functions. It's designed to detect arc faults, which are dangerous electrical discharges that can cause fires. Appliances with worn cords, damaged internal components, or malfunctioning motors can create these arc faults. Excessive current draw from a failing appliance can also trip the breaker. When testing appliances, be sure to use a properly grounded circuit that is not protected by the AFCI breaker you are testing. Secondly, concerning damaged NM-14 cable, this type of cable is commonly used in residential wiring. It consists of insulated conductors wrapped in a protective sheathing. If the insulation becomes damaged, for example, due to physical stress, pests, or improper installation, it can create a path for current to leak to ground, resulting in a ground fault or an arc fault. A megometer is essential for detecting these insulation faults because it applies a high voltage direct current to the cable and measures the resistance. A low resistance reading indicates that current is leaking through the insulation. Thirdly, overheated connections can occur at various points in the circuit, including outlets, switches, light fixtures, and junction boxes. Loose or corroded connections increase the resistance, causing heat to build up. This heat can damage the insulation on the wires, leading to short circuits or arc faults. When inspecting connections, look for signs of discoloration, melting, or burning. Make sure all wire connections are properly tightened and that the wires are securely fastened to the terminals. Also consider using antioxidant paste on aluminum wire connections to prevent corrosion. Fourthly, other electrical issues, such as loose neutrals or ground faults, can also trigger AFCI breakers. A loose neutral connection can cause voltage fluctuations and imbalances in the circuit, which can create arc faults. A ground fault occurs when current flows through an unintended path to ground. This can happen if a wire comes into contact with a metal enclosure or a grounded object. Use a voltmeter to check the voltage between the hot and neutral wires, as well as between the hot and ground wires. The voltage should be consistent and within the normal range, typically 120 volts in a standard residential circuit or 240 volts for high voltage appliances. In addition to these troubleshooting steps, there are a few additional tips to keep in mind. 1. Try resetting the AFCI breaker several times before assuming it is faulty. Sometimes a temporary surge or transient event can cause the breaker to trip. If the breaker resets and stays on, the problem may have been resolved. 2. Use the breaker finder to accurately locate the AFCI breaker associated with the circuit you are working on. This device sends a signal through the circuit, allowing you to identify the corresponding breaker in the electrical panel. This is especially useful in homes with multiple circuits and unmarked breakers. 3. Consider temporarily using a different type of circuit breaker, such as a standard breaker, for testing purposes only. This can help you determine if the AFCI breaker itself is the problem. However, it is crucial to remember that standard breakers do not provide the same level of protection against arc faults as AFCI breakers, so this should only be done for a short period while troubleshooting. 4. If all troubleshooting efforts fail, it is best to contact a licensed electrician for further assistance. Electrical work can be dangerous, and a qualified electrician has the knowledge, skills, and equipment to safely diagnose and repair complex electrical problems. They can also ensure that the electrical system is up to code and that all repairs are performed correctly. Also, consider the age of the AFCI breaker. AFCI breakers, like all electrical components, have a limited lifespan. Over time, they can become less sensitive and more prone to nuisance tripping. If the breaker is more than 10 years old, it may be worth replacing it, even if you cannot find any other obvious problems. When replacing an AFCI breaker, be sure to use a breaker that is specifically designed for the type of circuit you are protecting. There are different types of AFCI breakers for different applications, such as branch circuit AFCI breakers and outlet circuit AFCI breakers. Another important factor to consider is the load on the circuit. If the circuit is overloaded, it can cause the AFCI breaker to trip. An overloaded circuit is one that is drawing more current than it is designed to handle. This can happen if you have too many appliances plugged into the circuit at the same time. To determine if the circuit is overloaded, use a clamp meter to measure the current flowing through the circuit. The current should not exceed the rating of the breaker. The 2008 National Electrical Code, or NEC, provides guidelines for determining the proper size of circuit breakers and conductors. For example, NEC Section 210.20 states that overcurrent protection shall be provided in each ungrounded conductor for the degree of protection of equipment safety. In addition, consider the environmental conditions in which the electrical system is operating. Extreme temperatures, humidity, and corrosive environments can all contribute to electrical problems. For example, damp or wet locations can increase the risk of ground faults, while corrosive environments can damage electrical connections and wiring. When installing electrical equipment in these types of environments, be sure to use equipment that is specifically designed for those conditions. For example, use waterproof enclosures and corrosion-resistant wiring. Understanding the specific requirements of AFCI protection is crucial for ensuring electrical safety. According to the NEC, AFCI protection is required in many areas of the home, including bedrooms, living rooms, dining rooms, and hallways. The purpose of AFCI protection is to prevent electrical fires caused by arc faults. Arc faults are dangerous electrical discharges that can occur when there is a break or weakness in the insulation of a wire. These discharges can generate intense heat, which can ignite nearby combustible materials. In addition to AFCI protection, ground fault circuit interrupter, or GFCI, protection is also required in certain areas of the home, such as bathrooms, kitchens, and outdoor locations. GFCI protection is designed to protect people from electric shock. It works by detecting even small amounts of current leakage to ground and quickly interrupting the circuit. When working with electrical systems, always follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and insulated gloves. Always energize the circuit before working on it, and use a voltage tester to verify that the circuit is energized. Never work on electrical systems when you are wet or standing in water. If you are not comfortable working with electrical systems, it is best to call a licensed electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Also, document all troubleshooting steps you take. Keep a record of the steps you have taken, the results of your tests, and any repairs you have made. This will help you track your progress and identify any patterns or trends. It will also be helpful if you need to call an electrician for assistance. When documenting your troubleshooting steps, be sure to include the date, time, and location of each test. Also, include the make and model of any test equipment you use. This information can be helpful if you need to refer back to your notes later. Finally, remember that electrical codes and regulations can vary depending on your location. Be sure to consult with your local building department or licensed electrician to ensure that your electrical system is up to code. Following these troubleshooting steps, additional tips, and safety precautions should help you identify and resolve the issue of the AFCI breaker tripping. Remember to prioritize safety and consult a qualified electrician when needed.